Okay, here we are with some more problems. We're still solving those linear equations, and this is the third video in 3.2, and I think it'll be the last, so let's take a look at some examples. Here's the first one. Now we've got, in example 6, we've got some decimals involved, and again, shortly I'll show you a way to get rid of those decimals, but we have the option of just dealing with them. So the same thing applies. Clean up. Yep, we can clean up because there are like terms on the left, and that would give us 2.25x minus 1.72 equals 3.23. And I say let's keep up all the variables on this side and all the numbers on this side. So that means we've got to get rid of this 1.72. How do we do that? We do the opposite, so we add 1.72 to both sides. The results, 2.25x plus 0, but we don't have to write the plus 0, equals 4.95. And if we continue, we've got x almost all by itself. Who's in the way? Well, who's in the way is that 2.25, and what is 2.25 doing with the x? It's multiplying, so we know what we want to do to get rid of that is to divide this side by 2.25, which means we divide this side by 2.25. So over on the left, we've got our little x, and on the right, when we divide 4.95 by 2.25, we end up with, where are we? 2.2. So we have solved it. Next problem. Oh, we're back to fractions. Okay, so I'm going to try to be a little bit less talkative here and just see if you can see what I'm doing. Over on the side. Oh, I got to talk here. You'll notice we have 5y over 6. Another way to write that means the same thing as 5/6y. Just as 7y over 8, how else could you write that? Yeah, 7/8 y. So I'm still doing a little bit of work here on the side. I need to subtract those, so I need a common denominator, which would be 24. So I multiplied, so I'm going from, let me write down where I am here. 5y over 6 minus 7y over 8. And let me create a little bit more room here. y multiplied by 4, so I have to multiply 5 by 4, I would get 20. And then here, common denominator of 24 multiplied by 3, multiplied by 3. So it looks like all said and done, we're going to have a negative 1 over 24 times y. So I'm going to write that in, a negative 1 24th y minus 1/12. And if you will allow me, I'm going to get rid of all of my work down here. So now, I notice we've got only one term that has variables in it, and it is on the right, so I'm going to declare the right-hand side is where all of my variables are going to be, and the right-hand side is where my plain numbers are going to be. So this guy's in a good place. Who do we want to move? We want to move that 1/12. How do we do it? Well, what's that 1/12 doing? It's being subtracted, so we do the opposite. Add 1/12, add 1/12. The result of that, over on the right, this goes to 0, and anything plus 0, we can just write it like that. Oh dear, we're going to have to add 1/3 and 1/12, so let me do that down here. 1/3 plus 1/12, we need a common denominator, which would be 12. I'll do that second one for you. This would be 4/12, so we end up with 5/12. So we have 5/12 equals, and let me clear this. Okay, we're almost there. We've got, we want y all by itself. What's in the way? That negative 1/24. So we're going to multiply both sides by the reciprocal of that. Okay, so just remember, dividing by -1/24 is the same thing as multiplying by the reciprocal, which is a -24. So I'm going to multiply both sides by a -24. And when I do that, if it helps, you can put that over 1. The result of that over on the left, this is going to cancel. We would end up with a -10. And over on the right, just it's getting a little bit messy there, but we're going to cancel everything. Y, and we know, let's just turn that baby around. Y equals a -10. And again, we can check it, but I'm going to kind of zoom through these videos a little bit and take a look at one more example. And let me just check my time. Okay, I'm doing well here. Next example. There we go. Okay, this kind of example throws students off, but it works the same way. So, same process. Can we do anything on the right or on the left? No, there's nothing to be done there, nor on the right. So step 1, nothing to be done. We go on to step 2, which is to gather all of our variable terms on one side. Well, I see we have 2 variable terms. There's one over here and one over on the other side. So let's get them both on the same side. And it doesn't matter which side, it's up to you. Okay, so I'm going to say, well, let's get them both on the left. Since that one's bigger over there, we won't end up with negative numbers. So how are we going to get this 2n out of this side? Well, what's being done? Nothing's being done to it, but what can we do to undo that? Well, remember, when you want to move whole terms, you add or subtract them. So I'm saying, okay, what happens if we subtract 2n? Does that get rid of all of the n's on the right? Yeah, because what do we have left on the right? We have 2n minus 2n is 0. Okay, so I don't want to forget, if I did that on the right, I've got to do it on the left. Well, it's not 25, but it is 2n. So these went away to just 0. 7n minus 2n is 5n. Okay, do not let that little 0 throw you off. If you couldn't see it, what would you do to get n all by itself? Well, let's take a look and see what's happening with n now. We've got that 5 in the way. What's it doing? It's multiplying. So we want to undo that by doing the opposite, and the opposite of multiplying by 5, divide by 5. You got to do it to both sides. 5 over 5 cancels to 1, so we have 1n. And what is 0 over 5? Remember that from chapter 1, I believe it was? 0 over 5, the 0 is over. Over starts with an O that looks like a 0, so our answer is n equals 0. And this one, I have 30 seconds to check it. Okay, so back in the original equation, 7 times 0 equals 2 times 0. Does it? Well, let's give it a question mark. So this is our check. 7 times 0 is 0. 2 times 0 is 0. So woohoo! We got an A on this. And that is it for 3.2. I will see you in 3.3.